Right, and so begin with the mechanics section of our flashback. Okay, so we've got a wooden crate of 20 kilograms pulled in a straight line along a rough horizontal floor using a handle attached to the crate. The handle is inclined at an angle of alpha to the floor, where tan alpha is 3/4. The tension in the handle is 40 newtons. The coefficient of friction between the crate and the floor is 0.14. And the crate is modelled as a particle and the handle is modelled as a light rod. Using the model, find the acceleration. So we're looking for acceleration. In the mechanics question, generally it's a good idea to read it twice. First time you read it, you kind of get an idea of what the question looks like. Luckily enough, we've got a diagram in this one. Okay, but I'm just going to do my own little diagram. So a wooden crate of mass 20 kilograms. They said to model it as a particle. So there's my particle, 20 kilograms. So 20g. It's pulled in a straight line along a rough horizontal floor. So remember, it's going to be rough, so there's going to be friction. Using a handle attached to the crate. The handle is inclined at an angle of alpha, where tan alpha is 3/4. Now, one thing you shouldn't do, you should not be doing tan inverse at 3/4 to find alpha. When you get told this kind of information, you draw yourself a triangle, and tan alpha means opposite over adjacent. That means the ratio between the opposite side and the adjacent side is 3 to 4. And if that's the case, then the hypotenuse side must be 5 using Pythagoras. And so now from this triangle we can say that sine alpha is 3/5 and cos alpha is 4/5. Okay, so what's the next bit? The tension in the handle is 40 newtons, so we've got 40 newtons going that way. Away from the particle. The coefficient of friction between the crate and the floor is 0.14. So I know that because I've read this twice. It asked me for the acceleration. So the particle is moving, and so friction must be at its maximum. So we can say that F is equal to 0.14 R. The crate is modelled as a particle, and the handle is modelled as a light rod. Right, so we're going to have friction going this way, so we can put that as RF. We're going to have R going upwards, and it's going to be accelerating forwards like that. And this is all our information. This is everything from that we've been given. We were also told that the angle to the horizontal was alpha, and so we can draw in our horizontal and vertical components of the angular force 40 newtons. So let's look at what's acting in the vertical plane. So we've got several forces acting in the vertical plane. We've got R here, we've got this force here, and we've got 20g. So if we resolve vertically, we've got R going upwards, we've got this vertical force here, that's going to be 40, and because it's opposite the angle, it's going to be 40 sine alpha. And that's also going upwards, so we're going to add it. So add 40 sine alpha, and then you've got the 20g going downwards. Take away 20g. Now this particle remains on the ground, it doesn't bounce along it, and therefore the vertical forces must be balanced, and so it equals 0. So now we can say that R plus, remember we wrote down that sine alpha as 3/5. So 40 times 3/5 minus 20g equals 0. And actually we could go on and work out R in this case. So that's going to be 24. It's going to be negative plus 20g. Most of the time I prefer to just leave my answer in this kind of form, and we'll work out and then we'll put it in the calculator with our g's and stuff. So remember, we're trying to work out the acceleration, but the acceleration is in the horizontal direction, so we should probably resolve horizontally. So I've taken to the right as positive in this case. So what's pulling it to the right? Well, that's this horizontal component here, okay, and then what's pulling it back? Well, we've got friction pulling it back, and that's the only two forces acting in the horizontal plane. The first one is going to be 40 cos alpha. It's next to the angle, so it's going to be cos. So 40 cos alpha pulling it forwards, and then you've got friction pulling it down backwards, and this is equal to, and it's not equal to 0 this time, it's actually accelerating, so this is going to be equal to ma. M is 20, and acceleration is what we're trying to work out. That's 40 times, and we wrote cos alpha was 4/5, take away friction, but friction is equal to mu r, so 0.14, and then behold, this is where we need the r that we worked out earlier, so mu r, so mu is 0.14, and then r is minus 24 plus 20g, and that's equal to 20a. So what's that? That's 32. Take away 0.14 times minus 24 plus 20g, all divided by 20, and that's going to give me a. And now I would put this into the calculator, and it gives me a is equal to 0.396 meters per second squared, and we should give our answer to 2 sig fig, 2 significant figures, because we used 9.8. We should not go more than 2 significant figures when we've used 9.8. Just stick to 2 sig fig, and that's the acceleration in this question. Okay, so 6 marks. Generally, they're quite generous about method marks for resolving. So we have a method mark here, and then an accuracy mark for working out r, and a method mark for resolving horizontally, accuracy mark for getting the values correct and subbing them in correctly. You'll also get a mark for writing down f equals mu r and then subbing it in. So we subbed it in here, and then the final mark for getting the answer correct. In mechanics, we find that they're quite generous in terms of giving method marks out, so it's well worth trying to resolve horizontally or vertically, and trying to get your equations in motion, so your f equals ma equations.